How can we solve this initial value problem? This is a separable differential equation, and it has an initial value, that is, y of 3 is equal to minus 6. So we're going to get a unique solution. The independent variable is t, and that's usually time, and the dependent variable is y. Let's first put y on the other side of the equation. Next, we'll separate the variables. Put everything involving y on the left and everything involving t on the right. Next, we can integrate both sides of the equation. Now observe that the antiderivative of 1 over y is the natural log of y. And then the antiderivative of 1 over 1 minus 7t is the natural log of 1 minus 7t times negative 1/7. Note that we put the variables inside an absolute value, since the domain of the log function is just positive numbers. Now we can isolate y by raising e to both sides of the equation, since the exponential and logarithmic functions are inverse functions. This is what we get on the left side. And then raising e to the right side, we get using various laws for exponents. Now, using the fact that they're inverse functions, on the left we get the absolute value of y, and on the right we get e to the c times the absolute value of 1 minus 7t raised to the negative 1/7. Now we can eliminate the absolute value signs by writing y is equal to plus or minus e to the c times 1 minus 7t raised to the negative 1/7. Our solution has to be a function, so it has to be either plus or minus e to the c. So we'll let k be that constant. So the plus or minus gets absorbed into a new arbitrary constant. So what we end up with is y is k over 1 minus 7t quantity to the 1/7. So now we can use our initial conditions to find what k must be. And we had y of 3 was equal to minus 6. So let's plug those values into the equation to solve for k. So when we do that, this is what we get. And we can simplify that a little bit. And then solving this for k, we get k is equal to 6 times 20 to the 1/7. Then plugging that back into the general solution gives this. That is, y is equal to 6 times 20 over 1 minus 7t to the 1/7. And that's our final answer. So here, using Desmos, I've graphed 3 different particular solutions to this differential equation. In the green, y of 3 equal to minus 2 for that initial value condition. In the black, y of 3 is minus 6, which we just did. And in the blue, y of 3 is minus 10. Notice they don't intersect, and they all have a vertical asymptote at t equal to 1/7. So that's it. Thanks for watching.